Is the transformation a dilation? If not, which property or properties are not preserved? Let's take a look. We have triangle ABC transformed to triangle A prime, B prime, C prime. And the properties of dilations pretty much boil down to three simple ideas. One, that the corresponding angles are congruent. So A would be congruent with A prime, B with B prime, C with C prime. The second is that the sides that are corresponding have the same ratio. And we'll calculate that in just a minute. And the third is kind of a summary of all the other properties that have been listed in the lesson, is that it just doesn't look funny. I mean, it really looks like if you take this triangle ABC and you either increase or decrease the size and the shape doesn't change. Okay, so let's look at the angle measures. Now A to A prime, B to B prime, C to C prime. Just going to do this by inspection. They do look like they are congruent. Now we're going to do the ratios of the sides. So let's do A prime B prime to AB. Now A prime B prime is 12 and AB is 4. So that's simply 3 to 1 when you simplify. Now let's look at B prime C prime to BC. Now B prime C prime is 6 and BC is 2, which simplifies to 3 to 1. Okay, looks good. So far we're 2 for 2 as far as finding the same ratio. But you can't stop here. You have to make sure all the ratios are the same. So let's look at A prime C prime to AC. Now A prime C prime, it's not a horizontal or vertical line. So what we're going to have to do is use the Pythagorean Theorem to find the length of A prime C prime. Now we already know the length of each leg. We just found it. A prime B prime was 12. B prime C prime was 6. So let's calculate over here. A prime C prime squared is going to be, I'll just write 6 squared plus 12 squared to represent the two legs of that right triangle. So that is 36 plus 144, which is 180. So that means A prime C prime squared is 180. So A prime C prime is square root of 180. And that can be simplified. I know there's a perfect square of a 9 in there, 3 times 3 because of the 18. So let's just look at this for a second. 180 is 18 times 10, which is also 9 times 2 times 5 times 2. Okay? Now 2 times 2 makes 4, so this is really square root of 9 times 4 times 5, like that. Okay, now what this means, there are two perfect squares in here. So to simplify this, I can write it as, and I'm going to move up here, square root 9 times square root 4 times square root 5. And square root 9 is 3, square root 4 is 2, and then square root 5, well, that's still square root 5. So we have 3 times 2 times square root 5, 3 times 2 is 6, so we have 6 square root 5. Now all I did here was just do some simplification of this radical of 180. Now it's a lot of steps, but it'll be worth it in the end, as you'll see in a minute. So A prime C prime is 6 square root 5. Okay, now let's look at AC. Now we have the lengths of AB and BC, 4 and 2. AC squared is 2 squared plus 4 squared. which is 4 plus 16, which is 20. So AC squared equals 20. That means AC equals square root 20, which is the square root of 4 times 5, which is square root 4 times square root 5, which is, the square root of 4 is 2, so it's 2 times square root 5. Okay, so AC is 2 square root 5. Now look what happens here. We can simplify. These square root 5 simplify, they divide out, which leaves 6 over 2, which is 3 to 1. Okay, 3 to 1, 3 to 1, 3 to 1. All the corresponding sides have the same ratio. So we can conclude that we have a dilation here. Okay, now let me just go back and summarize. The idea of finding the dilation here was pretty straightforward. We compared the corresponding angles, they look congruent, and we also divided the side ratios, and they all came out to be the same ratio. And there's nothing unusual going on with the transformation. Everything looks like it's in place as far as linearity and all that, and betweenness. And there was quite a bit of calculation going on here as far as determining A prime, C prime, and AC. But don't get bogged down by the details. Just think of the big picture, what you were trying to do. You're trying to compare the ratios of the sides, and then of course there was a little bit of tediousness with reducing these radicals. But you can see it did work out 3 to 1 for all three pairs of corresponding sides.